And the last section of our final starts by asking us to do an indefinite integral that requires u substitution. In this case, u is the thing being taken to the fourth power. So I set up u equals x squared minus 8. When I take the derivative of the left, I get du. When I take the derivative of the right, I get 2x dx. The good news is we already have 2x dx right here. It can be replaced by du. That's not always going to be the case. If all I had here was x dx, I'd have to introduce the 2 and put a 1/2 out front. In this case, I can just say that this changes to the integral of u to the fourth du. If I integrate u to the fourth du, that gives me u to the fifth over 5 plus c. Last step, put back in what u was, x squared minus 8 to the fifth over 5 plus c. Please don't forget this plus c. It definitely makes the question right or wrong. For number 18, we have the same general idea. It's just a little bit different how we need to set up this u substitution. In this case, u needs to be the bottom. U equals x minus 5. When I take the derivative of the left, I get du. When I take the derivative of the right, I just get dx. So this 8 is unnecessary. That's why I'm going to bring it out front. Instead, I now have the integral of 1 over u du. We know how to integrate 1 over u du. That gives us the ln of the absolute value of u. So in this case, it becomes 8 the ln, absolute value of u, plus c. Again, just need to clean it up slightly. 8 the ln of the absolute value of, instead of u, what u stood for, x minus 5, plus c. Keep stressing this plus c. Please don't forget it. Please don't let it be the reason that you get a question wrong. Last question on the test here asks me to find the derivative of an exponential function. In this case, it's a function of x times another function of x, so it requires me to do the product rule. Product rule says first times derivative of second. Derivative of e to the 8x is e to the 8x times 8. This is really a chain rule, where essentially I have e to the u. The derivative of e to the u is e to the u du. I need to add to this second, which is e to the 8x, times derivative of first, which is 1. If I were cleaning this up, I would just call this 8x e to the 8x plus e to the 8x. Pretty sure they'd mark that right, but if you wanted to match exactly what they have in their answer key, they factor out an e to the 8x. So they call this e to the 8x times 8x plus 1. But again, I'm pretty sure they'd give you full credit if you left it right there.